today's session, students, starting the recording also. So we will first of all take a quick recap at the concept of scalar product that we discussed last time. Okay. Scalar or dot product. So we'd seen that the scalar product by definition was that it equals to the product of magnitudes multiplied by cos theta, where theta is the angle between the two vectors. Okay. And therefore we had seen that A dot B is a scalar quantity which can be positive when theta is acute, negative when theta is obtuse, or 0 when theta is exactly equal to 90 degrees. So for perpendicular vectors, the dot product becomes 0. Okay. And we had seen various properties like the fact that the dot product is what we call distributive, okay, then commutative, etc. So we had seen A dot B is equal to B dot A. Okay. Then we had seen that A dot B plus C, this is the distributive property, is equal to A dot B plus A dot C. We had seen that dot product of a vector with itself is its magnitude square. Dot product of any unit vector with itself is 1. Okay. And dot product of standard unit vectors which are mutually perpendicular is 0, whereas dot product of unit vectors with self is unity. So then based on these properties, we had also seen that finally the dot product in component form, the dot product of two vectors becomes product of x components plus product of y components plus product of z components. Okay. So this is what we've learned about dot product so far, and this is from today. Okay. So just take a quick recap of this and let me know if there are any doubts with this part. If there's any difficulty with this. No need to write Prince because you have already written this. Just I'm reminding you of what we've learned in the last lecture. There's a quick recap of what we learned. Okay. But if there's any confusion with any of these points, just read it through and let me know. Then I will explain that point again. Okay. So I'm guessing all this is fine with you people. Okay. So now let us go on to understand a little bit more. No, this part will not be there for the DPT which you are having. I mean, it will be there up to scalar product only. Cross product will not be there. Yes, Dushan, that statement is correct. Okay. In the second tick mark, okay, I'll explain. This one, this is called distributive property. Okay, this one. This is called the distributive property of vectors. So for example, if the vector A is 3 I cap and the vector B is 2 I cap plus j cap, then we can write A dot B dot product with 2 I cap plus j cap. So it will become 3 I cap dot 2 I cap plus 3 I cap dot j cap. Now this will become 6, because I cap dot I cap is 1, whereas this will become 0 because I cap dot j cap is 0. So the answer becomes 6. So this method of calculating, this equal to this method of calculating dot product by the component method is also a property of the distributive function. It is a application of the distributive property. It comes from this property, which is called the distributive property. Prince, is it clear now? Okay. Yeah, so Dushant, it is correct in saying that A dot B can be written as AB cos theta, and therefore that is AX BX plus AY BY plus AZ BZ. So this statement on itself is also correct. Okay. Now let's move a little bit ahead now today, since we have understood all these things, and let us look at next thing, interpretation of scalar product or dot product. Okay, we have understood the definition and we have understood the formula for calculating it by component method, but what is the meaning? Kya hota hai? What exactly dot product gives us? Let's try to understand that. So that is called the interpretation of dot product. Okay, so if we are having two vectors, like let's say this is the vector E, and suppose in comparison, Achha, you people don't have vectors DPT kya? See, when you have vectors DPT, I'm not sure which batches are having vectors DPT. Whenever next it will happen, for you it will be up to, okay, up to dot product. If it is not having this happening this weekend, it will happen the next weekend. But kinematics DPT तो आपका हो गया ना? Prince, haven't you had kinematics DPT last week? Oh, achha, that was Orange House. Okay. Fine. So yeah, first, correct. I confused between you. So first you will have kinematics DPP and DPT, and next week after that you will have vectors DPT. So it will be up to dot product. Okay. Okay. So coming back to this, if this angle is theta, okay, now we have seen the definition of A dot B. Kya hota tha? It was magnitude of A into magnitude of B into cos theta. Now notice something over here, that if we look at the quantity B cos theta, okay, what is the quantity B cos theta? Wait a minute, let me rub this part first. So in the diagram, if you look at it, B cos theta basically kya hai? Let's understand that. So if we drop a perpendicular from the vector B onto vector A like this, now as if A was our x-axis, okay, then in this diagram you can see that this quantity over here, this is B cos theta. So B cos theta is what we say, the component of vector B but along vector E. See, just like previously we had seen कि suppose मेरा x axis ऐसा था, ठीक है, and there was some vector let's say C that is making an angle theta with this. So C cos theta was basically what? It was Cx. No, this was the component of that vector C along the x-axis. So like that here, instead of along the x-axis, it is along the vector E. So this quantity B cos theta is vector B's component, okay, along vector E. So therefore, the quantity A dot B, okay, which is AB cos theta, can now be interpreted in a new way. It can be thought of as magnitude of the vector A multiplied by the component of vector B along vector E. So this becomes the interpretation. This over here is the interpretation of the dot product. What is the meaning of dot product? So one way to interpret the dot product, it is basically what एक vector का magnitude multiplied by the other one's component parallel to it. Okay, so this becomes the interpretation of scalar product. So write this down, please, people. Okay, so in fact, that is why, for example, when we define work done, okay, that is why, for example, the work done by a force F, okay, yeah, I'll come back to that, through a displacement S is defined as the magnitude of force multiplied by the component of displacement along the force. Okay, जो हम 9-10 में commonly we just defined it as force into displacement in the direction of force. This is how we used to understand this, work done. So here the proper definition becomes that it is F dot product with S, because the moment we multiply F with S cos theta, so you can see that on a particle, suppose the force is acting like this. Okay, but the particle makes a displacement which is like this, from here to here. It makes a displacement like this. So we have to actually drop the perpendicular of this on this and calculate this quantity here. This becomes S cos theta. So this is the component of the displacement along the force. So that is what we mean by this term over here. Displacement in the direction of force. That is why we define the work done by dot product. Because the interpretation of dot product is that way now. Yeah, so displacement, Ian, actually depends on both the things, force and, I mean work done, sorry, depends on both the things, force, displacement, and the angle between them. It depends on all the three things. No. Or in other words, it depends on force and displacement in the direction of force. Yeah, any vector's component along any other vector becomes cos, like any vector B's component along A becomes what? B cos theta, where theta is the angle between them. That I've explained in this diagram, Dushan. Okay, that if I have two vectors A and B and the angle between them is theta, okay, then B's component along A, that becomes nothing but B cos theta. Similarly, we can say A's component along B, that will become A cos theta. Okay. So finish writing this down, I hope. Okay. So now likewise, since A dot B is equal to B dot A, okay, so we can say that magnitude of the vector A multiplied with component of B along A is the same thing as magnitude of B multiplied by the component of A along B. And that is B into A cos theta is the same thing as A into B cos theta. Okay, so it's one on the same thing. Okay. So whether we say force into displacement along the force, or we say displacement into the component of force along displacement, it's one and the same thing. And both are given by the dot product. Okay, so done with this. Now through this, we will learn another concept. Okay. Projection of a vector, let's say along another vector. Okay. So let's understand what this term means. So if this is my vector E and this is some other vector B, okay, and the angle between them is theta. Okay. Now next what I can do here is I can break the vector E into two components like this, as if this is along one axis and there's another axis perpendicular to B, which is like this. So the vector E itself can be broken into two components, or what we call two projections. One will be like this and the other will be like this. Okay. So we will give this a short form name E parallel and this one a short form name E perpendicular. So projection of a vector along another vector, this will be given by the symbol E parallel, where it means this is the component or projection of vector E along vector B or parallel to vector B, but in iijk form. When we say projection, we don't mean just the magnitude. Okay, when we say component, we mean the magnitude. So usually the term component refers to magnitude form, and the word projection refers to vector form. Yeah, Ian, I'll explain with an example and then you'll understand. Okay, so you can see that the magnitude of this is nothing but E cos theta. Okay, so E parallel is a vector of magnitude E cos theta and direction perpendicular to, parallel to the vector B. Okay. So it's the similar thing to what we discussed just now, that A cos theta is the component of a vector along another vector. But now we want to express that in vector form, not in magnitude form. So we give it a new name called projection, where this quantity will now become a vector quantity such that uska magnitude kitna hai, a cos theta hai. That is in this right angle triangle, if you see this is the base, so its magnitude is a cos theta. Okay, but what about its direction? Its direction is parallel to B, and that is why it is called the parallel component, or the component of A along the vector B, or parallel to the vector B. Now we will see that how to calculate this thing. We will use, so we will use dot product method to calculate this. Okay, so just note this down first, then we will discuss with examples and it will become more clear. Don't worry about the second one right now, A perpendicular. I'll come to its definition. First, just understand this part, A parallel, or the projection of a vector A, which is along another vector B. Okay, so next thing we'll see is that because this is a vector which has a magnitude of A cos theta and a direction parallel to B, therefore, as a vector, it can be expressed as its magnitude, which is A cos theta, multiplied by a unit vector, which is giving its direction, where B cap is the unit vector parallel to vector B, given by the simple formula that B cap is vector B divided by its own magnitude. So ultimately, this thing that we're looking for, the projection of vector A along another vector B, this projection, this is given by this simple formula now. Okay, but here now, how to calculate A cos theta? Okay, so next let us look at that. So where B cap is this, okay, and E cos theta can be calculated from the simple formula E dot B divided by magnitude of B, since we know that E dot B by definition is AB cos theta. So if I divide AB cos theta by B's magnitude, what I'm left with? I'm left with A cos theta. So this is what your B cap becomes in that formula, and this is what your E cos theta becomes in the formula. Okay. So just note down this definition and this formula, and next when we look at numerical example, it will become clear, more clear what we mean by this. Okay, so have you finished writing this part down? Okay, so let us understand this with an example. Okay. We'll take a numerical example and understand all the various things that we can calculate using dot product method in that example. So suppose a vector E is given by the formula I cap plus root 3 j cap. Another vector B is given by the formula 2 root 3 I cap plus 2 j cap. Okay. Now we want to find, first of all, E dot B. Okay. Then secondly, we want to find the angle theta between vectors A and B. Okay. Then we want to find the component in magnitude form, that is, of vector E along vector B. And fourth, we want to find the projection of vector Okay, students, there's an internet interruption on my end. Just a second, I'll share the screen again. Okay, so actually the connection is a little weak because it's raining very heavily in my part. But anyway, let's see if we can continue. Okay, are you able to see the whiteboard clearly now, students? Okay, and voice? Is the voice coming properly? The voice is lagging. Okay. Screen is blurred. Screen should not be blurred. Okay, anyway, so if you can see the question, just start working on the question, people. Okay, so just try to calculate these four things. The first two are very easy. Tell me how much would be A dot B. Just apply the formula for it. Yeah, so A dot B kitna aega? A dot B should be coming out equal to 4 root 3. That is correct. Okay, this should come out to be 4 root 3. And this should come out to be 30 degrees. So first of all, check if you're getting these two answers. Okay, so let's start with this. The first thing, E dot B, which is by definition AB cos theta, but also in component form it is AX BX plus AY BY. It's only two dimensional, so AZ BZ are both 0. So it's 1 into 2 root 3 plus root 3 into 2. So that's how it becomes 4. Now, how do we get theta from this? Now, from here, you can see magnitude of A is square root of 1 plus 3 or 2, and magnitude of B is square root of this. Okay. So now coming back to this, so cos theta is nothing but the dot product divided by product of the magnitudes. So this is what we will use for the second part. This was the first part. So E dot B, first part में आ गया इतना. Okay, so substitute that over here. So cos theta is A dot B, which is 4 root 3 divided by magnitude of B, which you calculated, magnitude of B, which you calculated here. So that is root 3 by 2. So theta is cos inverse of root 3 by 2, which you know is 30 degrees. That's how we get the second part. So are the first two parts clear to all of you? Yeah, so Aman, the third part's answer will become how much? E cos theta, no? It will become, just check your calculation once more. So now see, as far as the third part is concerned, component of E along B in terms of magnitude, that is E cos theta. Okay, so that E cos theta can directly be calculated 2 into cos 30. So that is root 3. Or you can also calculate E cos theta this way. It is E dot B divided by magnitude of B. So E dot B was 4 root 3 divided by magnitude of B. Okay, so two methods of calculating this now. Okay. So this is the first three parts. Just make a note of this, then we'll come to part 4. Okay, now see, for the next part, what we'll do, Cross product will come later. There's a lot of things to cover about dot product. Yeah. So we'll complete those, then we'll come to cross product. Okay, so for the fourth part, let's understand the whole situation geometrically first. And it's easy to understand because it's a two-dimensional example. So we can always draw the vectors. So my vector E was I cap plus root 3 j cap. Okay. So it would have been a vector which is like this. It's of magnitude 2 we saw. And this angle will be 60 because tan inverse root 3. Now similarly, if you look at the vector B was 2 root 3 I cap plus 2 j cap. Okay. So magnitude of the vector B was 4 units. Vector B is something like this. And this angle would have been 30. And this magnitude is 4. Okay. So that is why when we drop the perpendicular on B from the vector A, this thing is what we are looking for now. So this is the projection of vector A along the vector B in vector form, or what we say is I cap j cap form. This is what we want to calculate now. Okay. So in the diagram we can see that this angle is 30 degrees. So we can see that E parallel will have a magnitude of E cos theta or 2 cos 30, which is root 3, which you already calculated. So that's the same thing. But direction along B, so that means B cap. So B cap kya hai? It is a unit vector along B. So we'll calculate what that B cap is and then multiply E cos theta with B cap. So it will give me this arrow as a vector. Right now I know its magnitude is root 3, but I also need to understand its direction in terms of unit vector. Okay, so I need to understand that this quantity as a vector will become its magnitude, which is A cos theta, multiplied by a unit vector, which is giving its direction. Now, what is that unit vector? This is the unit vector of B. This is the magnitude. And this is the unit vector, which gives it direction. Okay. So this diagram is clear. So now try to calculate by that method, which I have showed you. Yeah, I know my internet connection is quite unstable, guys, because it's raining very heavily here. But at least we will complete this, and I'll try to discuss some of the questions of assignment assignment number 6. So any doubts with the diagram? The angles, the magnitudes, all these things are clear in the diagram so far? Okay. So see, ये vector na, from our this thing we know that magnitude of A is 2 and the angle A is making with the x-axis is tan inverse of root 3. So that is 60 degrees. So A is of magnitude 2 and at an angle of 60 degrees. Okay. Then similarly, from the information given to us about B, we know that magnitude of B is 4 and we know that the angle is tan inverse of 1 by root 3. No? Divide the y component by the x component. So 2 by 2 root 3. So that is 30 degrees. So that is why we know that in any case we have calculated above also that the angle between vector A and B is 30 degrees. So if we drop a perpendicular from A onto B, ये जो magnitude है उसके component का A parallel के component का जो magnitude है A cos theta ये कितना होना चाहिए? It should be magnitude of A which is 2 into cos of the angle between them which is cos 30. So it should be root 3. Okay. Now the only thing is we have to express this component in vector form. When we express it in vector form, we call it the projection. Whereas when we express it in magnitude form, we just call it the component. So projection form में उसको या vector form में express करना है मतलब we have to multiply the magnitude over here with a proper direction or with a unit vector which gives a direction. Now what is that unit vector? It is a unit vector of B. Okay, so let's read this. So you can see that the component of vector A along the vector B, ये क्या है? ये A cos theta है. So that we have already calculated. The magnitude of A was 2 and cos theta was cos 30. So that's root 2. Okay. So now when we want to express as a vector, so we have to multiply its magnitude with the unit vector. So यहाँ पे B cap क्या है? It is the unit vector along the vector B. So that B cap should become what? It should become vector B divided by its own magnitude. So vector B was 2 root 3 I cap plus 2 j cap and its magnitude was 4. So B cap becomes how much? This. So this is B cap, whereas A cos theta was this. So now my vector A parallel will become the product of these things. The magnitude is A cos theta, which is root 3, and the unit vector is B cap, which is this one, root 3 by 2 I cap plus 1 by 2 j cap. So this becomes my final answer. This is the projection of vector A along vector B. Okay, people, is this clear now? Just note this down first. We will go over the steps again. So what we have calculated over here is this vector, the one which is shown with the red arrow. ये जो vector है, this one. This is now nothing but this. Okay, so this is clear. Okay, so let's go over the steps again for this last part. So let's understand totally freshly, okay, that given two vectors, how we find the projection of one vector on the other one. So once again, let's understand. Projection of the vector E, which was I cap plus root 3 j cap, along the vector B, which was 2 root 3 I cap plus 2 j cap. So this was the vector A, suppose. This was the vector B, suppose. So we want to drop a perpendicular here and calculate this thing as a vector. So we can see that that projection is E parallel, which has a magnitude of A cos theta and whose direction is along B. So it is given by this. So this becomes the definition. This is the definition. It is the projection along B. So it has a magnitude of A cos theta and direction along the vector B, so B cap. Okay. So now to calculate this, I need to calculate this thing separately, how much is A cos theta, and I need to calculate B cap, how much it is. Okay. So here A cos theta is very simple. A cos theta is nothing but A dot B divided by magnitude of B. So again, given these two vectors, we can see that dot product is how much? It is 2 root 3 plus 2 root 3 or 4 root 3. And the vector B's magnitude is how much? It is square root of x component square, so that is 12, plus y component square, so that is 4. So root 16. So this is root 3. Okay. So A cos theta is root 3. So in this formula, we will substitute A cos theta as root 3. And secondly, what about B cap? Just a moment, guys. And similarly, we will substitute b cap as the vector b divided by its magnitude. So that is nothing but again 2 root 3 I cap plus 2 j cap divided by its magnitude, which was 4. Okay. So b cap now becomes this quantity. So b cap will be substituted as this. So finally now, what is our vector projection becoming? It is becoming a cos theta, which is root 3, multiplied by b cap, which is you can write it like this, or you can write it like this. It makes no difference. So this is what this becomes. This is the projection of vector A along the other vector B. Okay. So in this, once again, I've taken you through all the steps that you require to find out this projection. So just go through this carefully. So the formula of the projection is this. It is A cos theta into B cap, where A cos theta is this length over here. It's the magnitude of A's component, which is parallel to B. So in this triangle, you can see the hypotenuse is A, this angle is theta. So the base is obviously how much? It is A cos theta. But now we have to also multiply it with a unit vector so that it becomes a vector in this direction. So that unit vector is which one? It is B cap. It is the unit vector along B. Yeah, we will discuss many more questions. Okay. This is a very critical part of application of dot product. So we'll discuss more questions also. Okay, so here's another easy question for you to work out using this method. Easy, I'm saying, because the values will be easy to handle. Just try this out. So E is 5 j cap, B is 12 y cap plus 16 j cap. Find the component of A along B in magnitude form. And secondly, the projection of A along B. So start working on this. So do this by formula, okay, like the formula we discussed above. So do this by formula. And then justify the answers to these two parts using this formula. Yes, Aman, your first answer is correct. Good. Rimjim, correct. Aman, just check your calculation once. Sorry, it's not correct. Aman, check your calculation again. Rimjim, your answer is correct. Yes, it's correct now. Akshat, I'm not understanding. What is the value you written? 23.3 यूनिट्स नहीं बेटा, कुछ गड़बड़ कैलकुलेट किया तुमने. Yeah, the angle with them will be 37 degrees. People. Okay, so let me just go by the formula-based method first. So the answer you should get for the first part should be 4. Okay. And the answer for the second part should become yes, Dushan, that's correct. So let me just take you through the first part. E का मैग्नीट्यूड कितना होगा? 5. It's not really required to. B का मैग्नीट्यूड कितना हो रहा है? It is 20. Okay. एंड ए डॉट बी कितना बन रहा है 80. It's 5 into 0, sorry 0 into 12 plus 5 into 16. This is your ax bx plus ay b1. So that's why it's becoming 80. So therefore, a cos theta nothing but 4. So this is the component of E along the vector B. That's all you need to do. यहाँ पे थीटा निकालने की जरूरत नहीं. You did not need to calculate cos theta separately. You just had to divide A dot B divided by magnitude of B. Sequence is very simple. Definition of A dot B क्या होता है? AB cos theta. So therefore, what is A cos theta? It is just A dot B divided by magnitude of B. Now what is A dot B? It is AX BX plus AY BY into D. Okay. So that we calculated here was 40. Sorry, 80. Okay. And what is mod of B? It is root of BX square plus BY square. So that was how much we calculated here. It was 20. So it's 4. So A cos theta is nothing but 4. And this is all we had to calculate now. यही तो निकालना था सिर्फ. Understood, Prince? Now this is clear. First part is all we wanted to calculate, nothing more than this. Is it clear? Right. Now second part, we want to find the projection of A along B. Okay, so let's come back to that. So second part, we want to find that A parallel vector. So what is the formula for that? It is nothing but A cos theta into B cap. Now A cos theta we've already calculated, we got that. Now what about B cap? B cap will be vector B divided by its magnitude. So it is 12 I cap plus 16 j cap divided by its magnitude. So that is your B cap and this is your A cos theta. So this is becoming how much now? This is becoming 4 into 3 by 5 I cap plus 4 by 5. So this is your parallel component. So this is the projection of vector E along the vector. Okay, people, this is clear fully. Okay, very good. Now do the third part, draw the vectors A and B in the xy plane. They're pretty easy to draw because A goes already along the y-axis, B only you have to worry about angle and all that, and justify your answer from the diagram. Okay, so let's come to the diagram part. So see, it's just to understand the question better. We've already solved it. Okay? What we have to do to find the components and the projection, that we've already done in the first and second part. But now we are doing this third part as an additional part so that we understand the whole process better. Okay? But in general, we will always use the method we have done above, the formula-based method, for finding the projections and the magnitude. I mean, the component along the vector and the projection along the vector. We always use that method only. Okay. So my vector E was 5j cap. So it's a vector of magnitude 5 along the y-axis. It's a vector like this. This was the vector E. Its magnitude was 5. And the vector B, that was 12I cap plus 16j cap. So you can see that this is at 53 degrees to the x-axis. And the magnitude of the vector B is 20. So the vector B in this diagram will become like this, something like this. You can see that this angle is 53 degrees and its magnitude is 20. Okay. So now we can see that what is the angle between A and B. Theta is 37 degrees. So if we drop a perpendicular here, this vector here should be A parallel. So A parallel should be a vector of magnitude cos 37. So 4, so that's correct. And direction at 53 degrees to x-axis. So its unit vector, so A parallel should be 4 cos 53 I cap plus 4 sin 53 j cap, which you will see will become 2.4 I cap plus 3.2 j cap. Because remember, cos 37 is, sorry, cos 53 is 3 by 5 and sin 53 is 4 by 5. So just use that over here. So this justifies both the answers. That magnitude कितना है उसका 4 है, which was the first part's answer, and projection कितना है, this is the second part's answer. So understood now how the whole thing is justified from the geometry. But of course we will see that when we have three-dimensional vectors, it is not so easy to justify with a diagram. But we always have the formula-based method. Okay, so what is the formula-based method? That A cos theta we can always calculate by dot product of the two divided by magnitude of the second vector, and this we can always calculate as this into the unit vector, where this gets substituted here, and B cap is of course B vector divided by its own magnitude. So this gets substituted here. So this is the formula based method. So in the beginning it seems a little bit complicated, but once you do few questions based on this, you will be able to understand it easily. You will see towards the end of exercise 1 in your module, there are a couple of questions based on this. And of course, I will be giving you worksheet 7, which will have questions based on this. Now let's come to worksheet 6 and let's discuss any doubts that you have in that. So next, let's come back to assignment or worksheet. Doubts. Just message me the questions you have doubts in people. Question number 2, okay, we'll start with that. Two and 3, okay. So people just open worksheet number 6 and start with question number 2. I mean, go through question number 2, I'll explain. So the vector A is given to us as 3 I cap plus 4 j cap, and the vector B is given to us as 7 I cap plus 24 j cap. Now we have to find a vector parallel to A and having same magnitude as B. Okay. So parallel to, so let us say this vector is, this vector, let's say it is C. So therefore, we know that magnitude of C should be equal to magnitude of B, should be equal to square root of 7 square plus 24 square. So that is 49 plus 576. Correct. So that's 25. Okay. So mod C should be equal to 25. And C is parallel to A. So that means C's unit vector should be A's unit vector. It's like this. If this is the vector E, then the vector C should be parallel to it. So if you draw a unit vector along the vector E, that should be the same as the unit vector along C. They should be identical. Okay. So the vector C, so unit vector of A is nothing but A divided by magnitude of A. So that is 3 I cap plus 4 j cap divided by mod of 3 I cap plus 4 j cap. Okay. So that is the same thing as 3 I cap plus 4 j cap by square root of 3 square plus 4 square. Okay. So by 5. So ये हो गया मेरा C cap. Okay. So the vector C is nothing but its magnitude multiplied by its unit vector. So 25 multiplied with the unit vector, which is this. So that becomes 15 I cap plus 20. So this is the general method of solving it, and also I would say the easiest method of solving it. I will discuss one more way of solving this because this is two-dimensional. So we can always solve it by another method, which is the geometrical method. But this is the general method that will always work for 2D, 3D, everything. And this also is the simplest way of understanding this question. So friends, hope it is clear by this method. So another thing you could have done here is, see, you could have understood that the vector E, because it's in the xy plane, it's very easy to draw. You would have understood that the vector E, which is 3 I cap plus 4 j cap, is like this. It's at an angle of 37 degrees. Sorry, 53 degrees, my mistake. 3 I cap plus 4 j cap, so it's more like this. So the vector C, now you know that it has a magnitude of 25, but it is parallel to E. So it should be like this. Okay. So you can see that C is basically becoming 5 times E. Okay. Or C is equal to 25 cos 53 I cap plus 25 sin 53 j cap. Right. Third question, then we'll come to 11th for Jim. So third question, beta, is very simple. You have to just use the formula that if this is the unit vector, the given quantity is the unit vector, its magnitude should be 1. So the quantity 0.4 I cap plus 0.8 j cap plus some C k cap. This is a unit vector. That means its mod should be 1. So it can basically, you will get that c square is equal to 0.04. So c can be plus minus 0.2. So in the option there's only plus 0.2, but it can be plus minus 0.2. So in the option it's only minus. Okay, let's come to 11th question. Fourth also, okay friends, I'll come to fourth. Ajay, tell me something, have we discussed direction cosines? People, we have not, okay, we've not discussed direction cosines. Okay, okay. So it's very simple. Let me explain direction cosines, then we'll come back to these questions. It's actually a bit of application of what we've learned today. I think I missed one lecture with you guys last week, so just got mixed up. So let us understand the concept of direction cosines of a vector. This is part of basically three-dimensional component form. So what we mean by it, let's understand. So given a vector with its three components, the angle of vector E with respect to x-axis is generally denoted by the symbol alpha. Similarly, the angle of vector E with respect to y-axis is denoted by the symbol beta, and with respect to z-axis is gamma. So cos alpha, cos beta, and cos gamma, these are collectively called, they are collectively called the direction cosines. That is the name we give it. So first of all, let's understand what is direction cosines. Okay. So these three quantities, they are called direction cosines. Now the next thing is, how do we calculate direction cosines? Okay. So they are given by a simple formula. Cos alpha becomes ax upon e. Cos beta becomes ey upon e. And cos gamma becomes az upon e. I'll give you the proof of this formula also. It's just based on that component or projection concept we were discussing earlier today. But first of all, you just write down the formula for this. Okay, so this is the direct formula. So using these formulae, we can find the direction cosines, or we can find the angles made by any vector with respect to the axis. Obviously, A over here is the magnitude of the vector. Capital A is mod A, or nothing but square root of sum of the squares of the components. E over. So like I told you, let me give you a simple example of the application of these formula. So let's start with something very simple. Suppose we have a vector which is actually lying in the xy plane. It's root 3 I cap plus j cap. Now you say find its direction cosines and alpha, beta and gamma, the angles. So by definition, by formula rather, by formula we will write cos alpha as ax upon a. So that will become root 3 by 2, because you can see that magnitude of the vector e. This, okay. So that is your first direction cosine. Cos beta, so that is 1 by 2, and cos gamma az is 0, so that is 0. So now, so these are the direction cosine. This is the answer to the first part. This is the, so if somebody asks you what are the direction cosines are collectively the three things: cos alpha, cos beta and cos gamma, and they are so much. Now next part, we want to find out alpha, beta and gamma. So cos alpha is root 3 by 2. That means alpha is cos inverse of root 3 by 2 or 30 degrees. Cos beta is half. So alpha is cos inverse half, sorry, beta is cos inverse half. So beta is becoming how much? It is becoming 60 degrees. And cos gamma is 0. That means gamma is how much? It is 90 degrees. Now it totally makes sense because this is a vector in the xy plane at 30 degrees with respect to x-axis. You can also see this now, that this is in the xy plane at 30 degrees with respect to x-axis. So obviously alpha should be 30, beta should be 90 minus 30 or 60, and gamma should be 90 because it should be perpendicular to the z-axis. It is in the xy plane, so it should be perpendicular to the z-axis. So that's why gamma is 90 degrees. Okay, so note down this example and do this next couple of questions yourselves. So find direction cosines and alpha, beta, gamma for these two vectors. So again, the first one is an easy example because it's a two-dimensional vector, though not in the xy plane, it is in the yz plane. Okay. And the third one is the general example, which is having all three components. Okay, people. So what are the answers for the first part? Yes, correct. No, cos alpha is 0 beta. For the first part, see, AX is 0, na? AY is 12. Huh. So A part's answers will be like this. Cos alpha is 0. Cos beta is 3 by 5. And cos gamma is minus 4 by 5. Okay. So this will tell me that alpha is 90 degrees. This will tell me beta is 53 degrees. And this will tell me gamma is an obtuse angle. It will be 180 minus 37. So 143 degrees. This is this part's answer. Yes, that's correct. Yeah, so cos inverse 1 by root 2 na, is 45. Right, Aman? Yes, Prince, correct. Okay, so second one, you will get cos alpha as 1 by root 2, cos beta as 1 by 2, and cos gamma as minus 1 by 2. So your alpha will be 45 degrees, beta will be 60 degrees, and gamma will be 120 degrees. Correct. Okay, so very simple. Huh? Okay, now this formula, why it is like this? It's ridiculously simple. It's very, very easy. From the definition of dot product. Okay, so let's just understand like this. For a vector E is having three components like this. If the angle with respect to x-axis is alpha, then A dot I cap should be equal to magnitude of A into cos alpha, because magnitude of I cap is 1. By definition, AB cos alpha, cos theta. So B के जगह क्या I cap. So magnitude is unity and the angle is alpha. So now A dot I cap is nothing but AX. So cos alpha is AX by B. Now like that for beta and gamma also. Similarly, so these three. Okay, so the concept of direction cosine is like this. Okay. Now let's quickly come back to the 4th and 11th question in the exercise. So 11th question, Rimjam, you can directly apply. Achha, one more thing, just before we forget. Okay, so this is one. Now secondly, that from these formulae, so this is a condition or a property of direction cosines. Okay. And a special case of this we'll discuss next also. If one of them is 90, then the sum of the other two have to become 90. So for example, if I tell you that alpha is equal to 60 degrees, beta is equal to 135 degrees. So gamma is how much? So you can see that cos square alpha plus cos square beta plus cos square gamma must be equal to 1. So cos square 60 is cos 60 is half. So this will become 3 by 4. 1 minus 3 by 4 will become 1 by 4. So cos gamma must be plus minus 1 by 2. So that means that gamma is either 60 degrees or 1 by 2. It has to be one of these two. Yes, Amma. Okay. So that is like a constraint. Yes, we can take any of them. But the answer to this particular question will be like this: that if alpha and beta are this, then gamma के दो possible values हो सकते हैं. But cannot be any other value like that. And within this only you can see it's part of this property only that because of this now you have if gamma is 90 degrees for example, that means cos gamma is 0. That means cos square alpha plus cos square beta must be 1. That means alpha plus beta must be 90 degrees. So that means this is a 2D vector in xy plane. Similarly, if beta were to be 0, beta were to be 90 degree, implies cos beta is 0. So that means cos square alpha plus cos square gamma would be 1. That means alpha plus gamma would be 90 degrees. So again, this is showing us that this is a 2D vector in the xz plane. Okay. Similarly, if alpha is 90 degrees, then cos square beta plus cos square gamma would be 1. So this is a 2D vector in yz plane. See this condition, if I say that cos square alpha plus cos square beta is 1, and I compare this with sine square alpha plus sine square plus cos square alpha, this is an identity. If this is the case and this is an identity, that means now compare these two. So cos square beta must be equal to sine square alpha. That means beta must be equal to 90 minus alpha, or alpha plus beta must be 90 degrees. So trigonometrically, this now means this. So I mean, this is just an obvious point from the above now, okay, because the sum of the squares of the 3 direction cosines is 1. So if any one of them is 0, then the sum of the squares of the other 2 have to be 1. So they have to be complementary angles. Okay, so question 11 Rinjim is, I think, a direct application of this concept only now. You have to just use the property of direction cosines that the sum of the squares is unity. Okay, you will get it from that. Question 11 in worksheet 6. Ajay, question 11 is slightly different. Cos alpha is given to us as 3 by 13. Cos beta, the direction cosines are given to us minus 4 by 13, and cos gamma is given to us as 12 by 13, and the magnitude of the vector is given to us as 65. So now we have to find ax, ay, az. So this is a reverse question. So ax is magnitude of a into cos alpha. So 65 into 3 by 13. So 15. Similarly, ay will become a cos beta. So here it will become minus 20. And az will become a cos gamma. So it will become 60. So the vector A will be 15 I cap minus 20 j cap plus 60 j cap. Okay. And question number 4. Friends, for question 4, you just use this formula that cos theta is equal to A dot B divided by AB, like we did that question today. So the two vectors are given in component form. Just use that. So vector A over here is I cap plus j cap. Vector B over here is 2 I cap plus k cap. So, sorry, 2 I cap plus 2 k cap. So A dot B कितना हो जाएगा? A dot B will be 2 and mod A कितना है? Root 2 and mod B कितना है? Root 8. So this is becoming 1 by 2. So that means theta is 60 degrees. Alright, people. So with that, we will conclude today's session and complete worksheet 6, and I will send you some questions to do from the module exercise, because the next worksheet 7 we will do after discussing about cross product also. Or I can send you worksheet 7. Most of the questions are to do with projections. There will be a couple of questions based on cross product which you can leave out, which we will discuss in the next lecture and you can complete. Okay. Alright, so that's it for 8th question. Yeah, Prince, I'll explain to you. The unit vector perpendicular to the resultant of A and B. Okay. So, Prince, in this, what you do? Let me share the document again. So, you know what is the condition for perpendicular vectors? No? When are two vectors perpendicular? When their dot product is 0. Okay. So, use that. So, in question 8, A is given to me, B is given to me. Okay. So, first find their resultant, A plus B. The resultant kya hai, you find this out. Then check which option is such that the given unit vectors dot product with resultant should be 0. Okay, that means that n cap is perpendicular to the resultant. This is the condition for it. Okay. Alright, anything else? Okay, so just give it a try with these concepts now. If any other question is also there, just give it a try with the concepts that you've learned in today's lecture. You should be able to solve most of the questions. 14th question. Two unit vectors are at 127 degrees. So scalar product is what? So it will just be cos 127, na beta? Because unit vectors का magnitude 1 होता है. So A dot B is AB cos theta. So A and B are both 1 because they are both unit vectors. And cos 127, you know how to calculate. It's minus cos 53. Okay, so just give the remaining questions a try with the concepts we learned today, and let me know if you have any other doubts later. Okay. So that's it for today's lecture, people. Wish you all the best and enjoy the monsoon.